Today's lecture will be DC characteristics of CMOS inverter. What is the DC characteristics? In our first lab, we try to make one curve like this, right? Remember? Remember, we try to make a curve like this from 2.5 at the middle. A curve like this. This here we had VO, that means V out. Here we have V in. In our first lab, we tried to make a curve like this. That was using software, using codes. Now we will do the exact same thing by our hand. That means by hand calculation. So before going into the math, these are actually your basic knowledge. You already know it. So we know we have three operations: cutoff, linear, saturation. We already know it. When we have cutoff, when we have saturation, we already know it. Now, characteristics curves are look like this. Okay, you already know the NMOS characteristics curve. This one, right? PMOS characteristics curve will look like this, the opposite. But what we have to do, we have to take this part and we have to rotate this. Rotate this means we need to draw the curve like this. Then we need to take the whole thing in this side, okay? Here, on top of the another one, okay? So this is for PMOS. PMOS, we need to rotate that. Then we need to overlap that, okay? Then after overlapping, you can see there are some points where our curves intersects, maybe here, maybe here, maybe here, something like that. Something somewhere our curve intersects, right? You got it? So these are the points we need to find out. We need to find the points. Then we will draw a curve. Okay, see, you can see. So we need to rotate that. Then we need to overlap that. Then we will get some points. Then we will find a point curve like this. Okay, that is the basic principle. Now, before going in there, let's see what is beta ratio effect. Beta ratio effect is called skewness of an inverter. Skewness. If beta P and beta N, they are equal, if they are equal, then we can call this is a normal inverter or normal skewed inverter or unskewed inverter. If beta P by beta N is more than 1, that means beta P is bigger, beta N is smaller, then we will call it high skewed. If beta P is smaller, beta N is bigger, that means that is less than 1, we will call it low skewed inverter. Okay? So what is high skew and low skew? This one, you can see. This is the VDD and this one is the middle one, the middle point, middle curve. If beta P and beta N are equal, that means their ratio is 1. The curve will go at exactly middle point, that means VDD by 2. If it is 5 volt, it will go through 2.5 volt. Understood? If they are equal. If beta P is bigger, that means if the ratio is more than 1, the curve will go towards right. More beta P means more right. Here the beta P was double, so it is going towards right. Here beta P was 10 times, so it is going more right. If beta P is smaller, beta N is bigger, it will go towards left. The curve will shift towards left. Look at this one. Here, beta N is double. That's why the ratio is 0.5. So it shifted towards left. Here, beta N is 10 times. That's why it is 0.1. It shifts towards the left more. So this is the effect of our what? Affect our beta P and beta N ratio. What it does, it actually minimize the noise ratio. Okay, let's talk about noise ratio now. Noise ratio, noise margin. Noise margin means if your graph goes through the middle, if your graph goes through towards the middle, what will happen? Here the noise margin is 2.5. Here the noise margin is 2.5. If it goes towards the left, here the noise margin is 1, here the noise margin is 4. So 4 we will not count. We will count the minimum one. So here your noise margin is 1. Previously your noise margin was 2.5. Now your noise margin is 1. So it minimizes the noise margin. Now I will go towards to the math. This is the math. Okay, you can see, right? You can see, right?
Yes.
Okay. All of you. Before going into the math, I want to develop 4 equations. Okay, look at this, everyone. Can you hear me?
Yes, sir. Yes, sir.
Okay. So I want to. I'm going to draw our CMOS inverter by using NMOS and PMOS, and want to develop 4 equations. Now this one is what? This one is VDD, right? Or VCC, whatever you say. This one is VSS, that means ground, that means 0. Now here, where we put our input? We put our input here, right? V in. What is actually input? Input is actually like this, right? So this is plus, this is what? Minus. This is our input. Where we put our output? Okay, output is a capacitor, or it can be an LED, whatever. So this is our plus, this is our minus. Okay, let's call it V out, VO. Now, I want you to focus here. This one is a what? This one is our drain. No, I made a mistake. This one is our source. This one is our drain. This one is our drain. This one is our what?
Source.
Source. This one is our what? Gate.
Gate.
This one is gate. Okay. Now, if we see, if we take a multimeter and if we take a reading here, from here and from here, what we are measuring? We are actually measuring VGS, right? Gate to source voltage. Can you see that?
Yes.
Can you see it is gate to source voltage? Gate to source voltage. So let's write VGS in which MOS? In NMOS. That's why I'm writing VGSN. VGSN equal to what? You can see I am not actually measuring VGSN. I am actually measuring V in, because this point and this point, they are same, right?
Yes, sir.
And this point, that means the ground point, and this point are same, right? Right?
Yes, yes, sir. Yes,
Okay,
sir.
so VGSN is equal to what? V in. Understood?
Yes.
Okay. Now I want to measure the output side. Output side means, so if I measure a voltage from this point to this point, what I am actually measuring? I am actually measuring the voltage between what? Drain to source, right? Drain to source. So can I write VDSN equal to what? And you can see this D point and this plus point, they're actually same, right? And this source point and this ground point, they're actually same, right? Why? Because this D point and this point, they are actually same because they are connected.
Same drain and
Source, and so this ground is grounded, that's why they're same. So what is now? What is this?
V out.
V out, exactly. So this is actually V out. So I'm going to write V out. So our VGSN is equal to V in, VDSN is equal to V out for NMOS. This part is for NMOS. Now for PMOS, I want to measure something. Okay, in this site, I'm going to erase this. This part is not needed. I'm going to erase this. And I'm going to erase this as well. Because we already found out this part. Now you see, if I want to measure a voltage between this point and this point, what I am actually measuring? What I am measuring? I am actually measuring VSG, not G, not GS. VSGP, PMOS. We are actually measuring VSGP. What is this? Okay, let's apply a KVL in this side. So VDD minus VSGP. Then we have another voltage called VGSN equal to what? Equal to 0. Again, let's go again. If you apply KVL, first you have VDD, then you have this voltage that is called VSGP, then you have this voltage that is called VGSN, then you have ground, that means equal to 0. So from this point, VGSN is already called V in, right? It is what? It is V in. So can I write V in this part?
Yeah.
So
Yes,
V in
sir.
is minus. So can I take the V in on the other side as a plus?
Yes, yes, sir.
So what we have? VDD
Minus
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 VSGP
equal to
equal to V in.
PN, yeah.
Okay. For the other side means for our output side, we apply a KVL. We should apply another KVL. What is that? We will apply a KVL in this side. So VDD
PDD minus
minus VSD
GSD
P
yeah.
VDSN equal to what?
equal
Now
Yes.
VDSN we can call it what? V out.
to
Yeah.
Since it is minus, can we take it on the other side? Of course, right?
Yes.
We can take it to other side. So then we will have a formula like this: VDD minus VSD
SD
P
P
equal to V out. So these two formula for PMOS. What are the formula? I'm actually finding out. I'm trying to find out some input-output relationship for NMOS and for PMOS. Take these four formula and all of you take a screenshot. All of you take a screenshot. These four formula will be needed. Okay, you got it?
Yes, yes.
Okay. Now we do not need this anymore. I'm going to close it. Now here, those four formula are written here. Okay, those four formula are written here. Understood?
Yes, sir.
Okay. Now we go for the math. First, for what is the math? A CMOS inverter is realized by using an NMOS of beta N is equal to 30 microampere per volt square, and beta VTN is equal to 1 volt. And a PMOS of beta P is equal to 30 microampere per volt square, and VTP is equal to 1 volt. Here VSS is equal to 0, VDD is equal to 5. Again, so beta N is given, VT is given, beta P is given, VT is given, VSS is 0, VDD is equal to 5 given. You have to find out the voltage transfer characteristics curve. Okay. So at first, what you have to do, first you have to develop the table for NMOS, develop the table for PMOS. How to develop? At first you have VGSN, then you have VDSN, then you have IDSN, then you have V in, then you have V out. All for saturation formula, saturation point. Why saturation point? Why? Why saturation point? Because your curve is like this. Now this part is linear. This part is saturation. Understood? Linear is constantly changing. Saturation is constant. It is not changing. So which part, if I give you 1 point and 1 point only, which point you need to draw the curve? This curve, right? Which point you need to draw it? If I give you the starting point, will you be able to draw the curve?
No.
No, because you can draw like these, okay. Or you can draw like these, right? Or you can draw like these. If I give you the starting point, it is not possible. If I give you the end point, is it possible? No, because you can draw like this. Or you can draw like this. Understood? The end point. It is not possible. So if I give you, what point I should give?
Middle.
No, middle means this one, right?
Yes.
No, this is not possible because if I draw like this, then no. I should give you a point. Wait. I should give you a point here. That means the bending point, right? If I give you the bending point, you know, before the bending point, it is linear. After the bending point, it is saturation. You know it, right? So 1 point means that bending point. That bending point is the starting of our saturation. That the starting of our saturation. Remember, our formula was like this. Our formula was like this. The VDS should be greater than 0 and less than VGS minus VT for linear, and for saturation the VDS should be greater than or equal remember this VT. So this part here in this curve, this linear part is for this one, and the starting point, that means this point is equal sign, and after that this is greater than. So which one we should pick? We should pick the equal sign, right? We should emphasize on equal sign. When they are equal, that is the starting point of our saturation, that means this point. So we will equal VDS is equal to VGS minus VT. So VDS is equal to what? VGS minus what? VT. That is the starting point of our saturation. That's why we are using saturation formula. This formula is saturation formula. That's why we are using saturation formula, and we are using saturation condition. This is the saturation starting condition. Okay, now. So VGS should vary from 0 to 5. Why? Because your lowest limit is 0, highest limit is 5. So vary from 0 to 5. So here we have taken one extra point, that is 2.5. Why? Because your beta n is equal to 30, your beta p is equal to 30. So the ratio is 1. So we know our curve will go at the middle. So that's why we have taken a point at the middle, 2.5. So 0, 1, 2, 2.5, 3, 4, 5. Understood, everyone?
Yes, sir.
Okay. Now what? Now your VDS. Your VDS should be what? Remember, VDS is equal to what? VGS minus VT. So your VGS is 0. Your VT is 1. So 0 minus 1, how much? Not minus 1, it is 0. Why? Because this VT is the deduction. Deduction means spending. I am spending something. If I have 0 money, how can I spend? So 0 money minus something spent is equal to 0, right?
Yes.
Understood? So you do not have any money. You have 0 money. Now you spend 100 taka. How much money you have now?
Sir, repeat what you say.
You have 0 taka, right?
Yes.
You spend 100 taka. How much money you have now?
Zero, sir.
0 taka, right? Because you cannot spend. So that's why 0 minus 1 is not minus 1, it is 0. So 0 minus 1, it is 0. 1 minus 1 is equal to 0. 2 minus 1, it is 1. 2.5 minus 1 is 1.5. 3 minus 1, 2. For 4, it is 3. For 5, it is 4. So what is this? What is this? This VGS? These VGS is actually these values. What is VT? VT is actually this value. So 0 minus 1, 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1, 5 minus 1. Okay?
Okay.
Now come to the IDS. So you already got these VDS and VGS. Now come to the IDS. The formula for IDS is equal to beta VGS minus VT whole square divided by 2. For first value, your VDS is equal to 0. So it is cut off. Cut off means current is 0. For next value, your VDS is equal to 0. So this is also cut off. So your current is 0. That means when your VDS is equal to 0, definitely that is what? That is cut off. That means definitely your current is what? 0. You already know it from our VDS or our IDS equation. You already know it. Now 2, for 2, we are getting 1. So it is not 0. So we have a value. So let's put it. Here our VDS is equal to 2. Let's put 2 here. Our VT is equal to 1. This one. So let's put 1 here. Our beta is equal to 30. Let's put 30 here. So 30 into 2 minus 1 whole square divided by key, divided by 2. So you got 15. What is the unit? Unit should be this unit. Whatever the unit you have here, you have unit here. Microampere. Understood?
Yes.
So it is 15 microampere. For next one, you will get 33.5. For next one, you will get 60. You will get 135. You will get 240. So you do not have to show all the calculation. You show 1 or 2. That is enough. Okay?
Okay.
Now come to the V in and V out. What is V in? Previously, I told you something like this. V in is equal to VGSN, right? VGSN is equal to V in, and VDSN is equal to what? V out. VGSN is equal to V in, VDSN is equal to V out, right? Let's get back.
Yes.
Which one is our, okay, which one is our VGSN? This one is our VGSN. So this one will directly go to the V in, right? V in and VGSN, they are equal. So 0, 0, 1, 1, 2, 2,
Yeah.
2.5, 2.5. So they are actually equal, right? 5, 5. Can you see that?
5, 5, 4, 4.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So this is actually clear. Now VDSN, this is your V out. So this one will be equal now. So
Yes.
0, 0,
Uh,
1, 1, 1.5, 1.5, 3, 3, 4, 4, right? They're equal. Can you see that?
yes, sir.
Yes, sir.
So actually, this column will be gone here, will be going here. This column will be going here, equal. So this table is finished. Understood?
Yes,
Yes,
yes.
sir.
Now let's go to the next table, PMOS. Again, from 0 to 5. Now look at this. This is SGP, not GSM. SGP, SDP. So again, the formula is same, similar formula, this formula. This is 0 cutoff. So value will be 0. Value will be 0. So this one 0 minus 1. Which one? This one? No, not this one. This one. This one, because this is for PMOS, this is for NMOS. So now 0 minus 1 is equal to 0. 1 minus 1, 0. 2 minus 1, 1. 2.5, 1.5. 3 minus 1, 4 minus 1, 5 minus 1. Okay? Directly. Now come to the IDS. For IDS, the same formula. IDS is equal to, or ISD. Here in case of this, it is ISD. ISD is equal to what? Beta P VSG VT whole square divided by 2. Again, your formula will be what? So let's put it this one. Let's put this one. Okay? 2 minus 1. 1 is this one. 1 whole square into beta. Beta, which beta? This beta or this beta?
The P beta.
Yes, P
P
beta.
beta.
So whatever the value, you have put it here and divided by
2.
2. So you will get 15. Again, you are getting 15. So let's put 15 here. If
Yeah.
you put this one, you will get 33.5. This one, 135. This one, 240. Fortunately, since our beta P and beta N are same, our value, this one and this one, will be same. Understood? If
Yes.
they are different, the value will be different. Okay? Got it?
Yes, sir. Yes.
Okay. Now for V in, let's get back again to our whiteboard. Look at this. Your V in is not directly VSG. It is VDD minus VSG. Your V out is not directly VSD. It is VDD minus VSD, right?
Yes.
Okay. So this time it will not go directly here. Not directly. It will not go directly, right? It will go after deduction from 5. So 5 minus VSG, then it will go here.
Yes. Pure.
So 5 minus 0 is equal to 5. 5 minus 1 is equal to 4. 5 minus 2 is equal to 3. 5 minus 4 is equal to 1. 5 minus 0 is equal to 0.
0.
Understood?
Yes, sir.
Similarly, next one, 5 minus 0. Now this one will go there, but after after deducted from 5. 5 minus 0 is equal to 5. 5 minus 0 is equal to 0, 5. 5 minus 1, 4. 5 minus 1.5, 3.5. 5 minus 2 is equal to 3. 5 minus 3 is equal to 2. 5 minus 4 is equal to 1. Understood?
Yes, sir.
So our tables are completed. Now we will go for what? We will go for graph. These two graphs we have to develop. Then you have to rotate this graph like this, like this. Then you have to place the graph on top of the first graph. That means this graph, like this. Then we will fill up some table. So you do not have to do this much of work. I'm going to teach you how to draw these at the first time, right? Then we will develop this table. Then we will what? We'll develop this table. Now, before going in there, I want you to take a screenshot of these two tables because you will be telling me the values from these two tables. Take a
Okay.
screenshot, all of you. Then you will help me. No, you will help me by giving some values. Okay, understood, everyone?
Yes, sir.
Now, let's go to the whiteboard. I'm going to create an axis first. Two axes for two MOSFET, one for NMOS, one for PMOS. This one is for IDS, that means for NMOS because D is first. This one is for ISD. Okay, actually no magnitude is required because ISD, because it is plus. IDS is plus, ISD is plus. Now what? In this scale, this is VDS, that means for NMOS. In this scale, it is VSD. Understood? So since our VDS is from 0 to 5, so let's divide it from 0 to 5. This is your 0, this is 1, 2, 3, 4, this is what? 5.
Five.
Next one will be what? 0, 1, 2, 3, 4. Here, which one is our output point? Which one is our output? VDS is our output or VSD is our output? Let's go.
VDS.
VDS is our output. That means this one is our output. Remember, let's call it VO. Okay, let's call it VO. Understood, my dear?
Yes, sir.
That means, okay. That means this point, that means these points are my outputs. 0, 1, 2, 3, 4, 5. This is my output scale. So I marked them. Now, which one is our highest current? Go to the table and see which one is our highest current. Maybe 240, maybe something like that. 240, right? 240?
Yes, sir.
240, yes, sir.
240. Okay, let's divide the scale accordingly. So this one is not needed, but for our graph, it will help us. This is 100. This is 200. So maybe this is 240. Maybe this is 250. Okay. So I divide my scale something like this. Understood? Maybe this is 100. This is 200. This is 250. Not 240. 250. Now come back. Go to the table and see for NMOS at first. We will draw the NMOS first. For NMOS, VDS 0, right? That means the first row. VDS 0. What is your current?
Current is 0, sir.
0. That means, okay, let's use the purple color for 0. For 0, your current is 0. Current is 0 means?
Cut off.
That means like this. Oh no, let's use a bigger one. Okay. Okay, cut off. That means it will go towards the 0. Understood?
Yes, sir.
Then what is the corresponding input? What is the corresponding input?
0.
Input is also 0. So let's write 0 here. Understood? For next one, for next line, again 0. What is the output? What is the current?
Again 0.
Again 0. Again 0. I'm giving a line. Again my what is my input that time?
1.
1.
1. So let's write 1. That is 0 and 1, they are actually both the same line. Okay, both of them are same line. Now next line, next point. Next, which one? For 1, right?
1.
VDS
1.
is equal to 1. VDS is equal to 1. What is your value? What is
Value
the
is 15, sir.
15, exactly. For 1, which one is 1? This one is 1, right? This one is 1, right? For 1 is 15. Which one is 15? This is 50. That means 50. This is 25. That means 25. This is 15, right?
Yes.
This should be 15. Okay, let's draw a line like this. Let's draw another line like this. Understood?
Yes, sir.
Now, what is the input on that side on that time?
Input is 2.
2. Okay, let's write 2 here. Understood? Now,
Yes, sir.
now for the next one, for 2. Oh, for 1.5.
1.5, sir.
1.5. How much? 1.5 is in between 1 and 2, right? In between. That means maybe here. Okay, how much is your current?
33.5.
33.5.
33.5. Okay, let's see 33.5. That means this is 50. This is 25. This is 30. Maybe this is 33.5, right?
Yes.
Okay, let's draw a line. Let's draw another line. Okay. Now let's erase the other points not needed. What is the input?
Input is 2.5.
2.5. Okay, let's write 2.5. For next one, for 2 maybe, right? How much?
Yes. So 60.
6.
60. So let's use a different color. 60. That means here it is 50. Maybe here is 60, right?
Yes, sir.
Okay. So let's draw a line. Let's draw another line. And let's write the value. What is the input?
3.
3. Okay. For next value, that means for 3, VDS is equal to 3. What is the current?
135.
135. Okay, let's use different color, red color. Okay, 135. That is this one. 135. This is 100. This is 150. This is, let's say this is 135. Okay, let's say this is a 135. Let's draw a line. Let's draw another line. Let's write the value. What is the value of input?
4.
4.
4.
Exactly. For 4, that means for VDS is equal to 4. How much is your current? Maybe 240, right?
240.
240. 240.
Yes.
Which one is 240? This is 250. This maybe this is 240.
Yes.
So let's draw a line. Let's draw another line. Now, what is your input now?
5.
5. Okay, everyone? Done?
Yes, sir. Done.
Okay. Now what? Now I want to draw a curve for PMOS. Now we will consider this scale. That means the lower scale, 0, 1, 2, 3, 4, 5. That scale. Now, for go to the PMOS and tell me for VSD is equal to 0. What is your current?
0, sir.
0, right?
Yes.
Yes.
Let's use the yellow color again. For 0, what is your
V.
what is your V in?
5.
5. Okay, that's why I have used the yellow color, because 5 and 5, they should be yellow. Understood? Now I'm going to use the red color now. For 1 or for 0? For 0 again, right? Because we have 2 zeros. So 2 currents, right?
Yes.
Let's draw another line. Now what is your input?
4.
So 4 and 5, they have the 0 line. Like the previous one, 0 and 1, we have the same line. For 4 and 5, we have the same line now. Understood? For
Yes, sir.
1, what is that? For 1, what is your current?
15.
15 is here. This one is 15, right?
Yes.
So I'm going to draw a line in this side. And like this. Understood? So what is your input?
Input is 3.
3. Okay. For next one, 2.5, right?
Yes.
So 1.5, right? So
No,
from 1
1.5.
to 2, from 1 to 2, you have how much? 33.5 maybe.
33. Yeah.
Yes.
Okay, this one. So let's draw the line. Like this, right? This is 2.5 input, right? Understood? 2.5. For next, that
Yes.
is for 2. What is the value?
6.
6. Okay, let's use 6. 60, right? 60. This is 60.
6, sir.
What is the input?
Input is 2.
2.
2. Yes. For 3, that means from for this point, what is the current?
135.
135. What is 135? Okay, let's use this color. What color should I use? Okay, let's use this color. 135. This is 135. What is the input?
1.
1. Okay. For 4, what is your what is your current?
240.
240 is here. Understood?
Yes, sir.
What is your input?
0.
0. 0. Let's write 0. Now I do not actually need this line anymore. Okay, now I need to start building one table. Let's build a table. This is for input. This is for output. That is for current. Now 1, 2, maybe 7. We need 7. We draw 6, something like that. Okay. Okay, now let's draw. Let's write. Here, first of all, for 0 number line, which one is 0 number line? 0 number line is this line, right? That means the purple line. That is going down, right? For NMOS side, from NMOS side, what is the 0 number line? 0 number line is a purple line. That means the ground line, something like this here, right? This one.
Yes.
Now here, look at this here. Here, which one is 0 number line? The top one. This one, right? These two lines, where they intersect, where they touch each other. The previous line and this line, where they touch each other. Here, or here, or here. Where they touch? Here?
Yes, sir.
Here. What is the value of VDS? What is the value of V? Okay, let's call it, let's write V in. Let's write V out. Let's write I. For V in is equal to 0 because we are dealing with 0, right? 0, number 0. What is the intersection point? Where they intersect?
This point here.
What point? What is the output? What is the value of V out that time at that intersection point?
5.
5. So we'll write 5. Understood? Intersection point, that means here. Okay? So I'm going to delete these. I'm going to delete these. No. Okay, now for 1, again, see, which one is our 1 line? For the lower part, the purple, the pink color, right? That means this one. And the previous one, where is our 1 line?
On top.
This one, right? Where they touch each other? Where they again 5, right?
Okay.
That means for 1 you are getting 5. Understood?
Yes, sir.
Okay. Now come again for 2. For 2, which one is our 2?
2.
2 line is this one. right?
Yes.
And where is our 2 line here?
This one.
Where they intersect?
Answer 4 point something.
4.5, right?
Yes, 4
They
point
intersect here, right? So I'm
Yeah.
going to write
4.5.
4.5. So for 2, I'm getting 4.5. Oh, by the way, what is the value of current at that point?
value of current is and one
No, current. This one is 100. This one is 60. This one is 33.5. This one is 15, remember?
yes,
So what is the value of current? 15, right? The value of current of that point is 15. Understood?
Yes, sir. Yeah.
that's 2. Yes.
Okay. You understood, I believe. So now 15. Previously, because they intersect
Zero,
there,
zero.
that value was 0 actually.
Yes, 0 0.
0, 0. Now for 3, let's write. For 3, which one is your curve? For NMOS? No. For 2.5, not 3. We have drawn something wrong. For
Yes,
2.5.
2.
For 2.5, which one is your curve? This one is your curve, right? And
Yes.
which one is the curve for this one? Okay, this one is your curve.
So 3 point
So they actually intersect in twice, in 2 places.
2.8.
So here and here, right? They actually intersect in these 2 points. So one is 1.5, another one is 3.5. So can I call it 1.5 and 3.5? What is the current?
33.5.
33. Yes. For next one, that means for 3, what will be the value?
For 3.
So this one is 3 line. Which one? This one is 3 line.
Yes.
And this one is 3 line. Where they intersect?
This one is 3 line.
0.5 maybe.
0.5.
0.5.
0.5. Exactly. So let's call it 0.5. What is the current?
Yes.
Current 6.
No. Current is here.
Current 6.
The intersection point current, not the highest current.
So
15, sir.
15.
15?
Exactly.
Oh,
Now for what? Now for the last one. Last 2 actually, not last one. Last 2.
Last 2. 4.
Now for 4, which one is the line? This is the line. For 4, which one is the line?
Yeah. It's 0.
They intersect at 0, right?
Yes.
Okay. So for 4, they intersect at 0. What is the current? Again 0 because they intersect at 0. For 5,
Also 0.
also 0. Right? You already know it.
Yes.
For 5, it is also 0 and your output will be 0. So this is my table. From this table, okay, take a screenshot if you need it. If you need
okay.
if you need this, take a screenshot, no problem. Okay?
Okay, sir.
Now if I need, we have to draw another curve. I'm going to erase this part. We do not need it anymore. Now I'm going to draw the curve. Pretty simple. Like this. This is my V out. This is my V in. This is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. This is also type. This is also that. 0, 1, 2, 3. 4, 5. Understood? Now let's put the points. For 0, the value is 5. That means for 0, the value is 5. Understood, everyone? For 1, the value is 5. That means for 1, the value should be 5. For 2, the value is 4.5. This is 2. 4.5 means here is 4, here is 5. The 4.5 should be here. Understood?
Yes, sir.
Okay, for 3, let's skip 2.5. Go to the 3. For 3, the value is 0.5. For 3 is 0.5. Here is 0.5. For 4, value is 0. For 5, the value is 0. Now, if I connect the line, oh, by the way, we missed 2.5. For 2.5, it is 1.5 to 3.5. This is 2.5. 1.5 will be here. 3.5 will be here. So connect the line. So if we connect the line, so this is our curve, right? Understood, everyone?
Yes, yes, sir.
Okay. For current graph, we have to do the same. B in, this is IDS. Again, 0, this is 1, 3, 5, 4. The value is what? 0, 0, 15, 33.5, 15. So this is 0. Let's say this is 15. This is 30. Maybe this is 33.5. So this is 15. So for, again, see, for 0, what is the current? Is 0.
0.
For 1, what is the current?
Also
0.
0.
For 4, current is 0. For 5, current is 0. For 2, current is 15. That means here.
Yes.
For 3, current is 15 here. For 2.5, that means in the middle, the current is 33.5. This is 30. This is 33.5. Understood? So
Yes.
now let's connect the line.
Zero.
Understood?
Yes, sir.
This is 33.5. We just write 33.5. So these are the two curves we can draw. I hope you understood.
Yes.
So you practice the same math. Okay, I'm going to go to the sheet. You practice the same math with different beta. You try with 15 and 15. Then you try with 15 and 10. Okay, at first you try 15, 15, then you try 15 and 10. Okay, got my point? Different values.
Yes.
So you try it and you get prepare yourself for the exam, because in the exam, if you are planning to answer it, you have to be cautious about your time, because this math will need 1 hour for you. See,
Yes.
for make you understand, I need more than 40 minutes. So for doing it, how much I need?
Approximately 1 hour.
Ma hadda isku dayanaa.
Waxaad isku daynaa. Adigu isku day Ibrahim. Nice.
Simple way waxaa.
Waa fuuda wala aad buu fuudaysaa.
Faham kaliya.
Marka macalinku video soo diro markaas ku fiican tahay qof soo day.
Ma hadda isku day leeyahay.
Ma oran isku day. Wax horan caawa isku daynani. Maxaa ka ma gashay horta?
Ay wallahi maalinkii mid ugu fudud bay u saaratay. Sibtar.
Hadda galaysa Soomaa.
Hadda galnaa si fiican baa hadda noo sii jilcayo.
Classica am Surya.
Bye.
Classica laga aamuso macalinka sharaxaad buu wadaa.
شعور ببلاصة.
إبراهيم
أشيك موبل كده.
إبراهيم كلاسك هو هذا كده هنا
codka aga dheer macalinkiisan maxaa la dhahaa yaabina codka aga rudi asaa ku haysaa
Hello.
Yes sir, yes sir.
Okay. Now you try. See this one. If you try to plan, if you are planning to answer it for the first time in the exam hall, you will fail. You will fail means you cannot finish it with time. This is my experience.
Yes, yes, yes.
So you practice twice before going into the exam. Okay. Otherwise, this is very easy. All of you, if you practice 1 or 2 times, you will get 10 out of 10 or 15 out of 15. Okay. But if you do not practice, that time you will fail. You will fail means not fail. You will fail means you will fail to complete it. Got my point?
Yes, sir.
Okay. So this is very easy but very long process. This is a very long process. So what happened? I'm going to take the extra labs. That means extra lab means those who miss the lab exams, they will be giving the lab exams now. The time will be 12 up to 12:30. After 12:30, we'll those who will left. That means maybe Hafiz will go somewhere. He can go. Then we will discuss on lab. And this Wednesday and Thursday, we will take extra classes. Because in previous 2 weeks, I missed several classes, right?
Yes, yes, of course.
I missed several classes, so I will make those classes on Wednesday and Thursday, because Wednesday and Thursday I do not have any classes. So I have free times, so you can come and not come. You can actually come on Zoom and you can have the extra classes. Is that okay?
Yes, yes, we are ready, sir.
You are ready? Okay.
Yes.
Hafiz?
Yes, sir. We are ready.
Okay, after your exam today, I'm going to release the test scores. All the test scores, whoever given, because I have the record, I will release the test record and you can see. And today I'm going to give you a report writing, because the lab report should be there. Now we have done 11 labs. I'm not going to ask you to write all 11 lab reports. I do not need. I'm going to give you a separate questions for your lab report. Maybe 1 or 2 design will be there. You make the design, you write a report like your lab report like sheets and submit it to me, the PDF. Got my point?
Yes, sir.
Maybe 4 to 5 pages, something like that. Not more than that.
Only one lab, sir.
No, not 1, maybe 2, something like that. I will give. And you do the lab, you perform the lab, you write a lab report and submit to me. Okay? Okay. So those who missed any of the exam, okay, write in the comment section, not here, like in our group, okay? In our group,
Okay.